All right, let's get started with 4.2, more application problems here. So again, what we want to do, as we saw with the last couple of application problems in 4.1, the most important thing is to understand what is missing or what you're asking to find. So step 2, identify what you're looking for, and step 3, choosing variables to represent those quantities are going to be a good choice. So as we had adult tickets, children tickets, I used the letters A and C to represent those people. Then we got to turn it into a system of equations. Number 4 says, all right, in order to do that, remember we said you have to have an object equation. Number 2, you're going to have a rate equation. Use your algebra techniques to solve, which means probably elimination or substitution technique, and then check your answers to make sure that they make sense. So if we're trying to find the number of tickets again, you can't have a negative ticket, you can't have a decimal ticket or a fraction ticket. All right, so first problem, here we go. The sum of two numbers is 67. The difference of two numbers is 39. What are the two numbers? I'm going to just use x and y since I'm not representing anything. Now, what some people would encourage you to do is if you're going to have two numbers, you might have a big number and a small number. So you might want to use b and s. All right, so we might want to say x is the bigger number here, y will be the smaller number. So find the sum of the two numbers. Okay, x plus y equals 67. The difference between the two numbers, if we say x is the biggest, then it's x minus the smallest, so we get a positive number. Well, here's my system. My y's are already opposite. Let's add those together. 2x, y's cancel. 67 plus 39 is 106. Solve for x. We divide by 2. We get x is 53. Pick either equation. I'd probably go with the first one. Substitute in the 53. All right, 53 plus y equals 67. Subtract over 53. Y is equal to 14. There's my two numbers, 53 and 14. A bag is filled with green and blue marbles. There are 49 marbles in the bag. If there are 17 more green marbles than blue marbles, find the number of green marbles and the number of blue marbles in the bag. So G for green, B for blue. Total marbles in the bag, 49. So G plus B equals 49. Next we have there are 17 more green marbles than blue marbles. So that puts G and B on opposite sides of the equal sign. But in this phrase, who's bigger? There's 17 more green. So there's more green than blue. So what we need to do is add 17 more to the blue. So by doing that, now we have G by itself. I'm going to take B plus 17 and put it into the first G. So B plus B is 2B. We'll subtract the 17 from 49 to get 32. Divide by 2. B is 16. Take that 16, place it into the B where G is by itself. 16 plus 17 is 33. So we have 33 green marbles, 16 blue marbles. Number 3, Emmanuel has some quarters and dimes. He has 11 coins worth a total of $1.85. How many of each type of coin does he have? Okay, identify. Quarters, Q, D for dimes. Now it says he had 11 coins, so Q plus D equals 11. Now, your rate equation, how much is a quarter worth? It's worth 0.25. So multiply that to the Q. The dime is worth 10 cents, 0.10. And the total value, since this is now a rate equation in dollars, it's $1.85. Now take your object equation. Who is the smallest coefficient? It's 0.10. We're going to take its opposite and multiply it to everything up here. So negative 0.10Q minus 0.10D equals 11 times a negative 0.10, negative 1.10. Add together. Whoops, I guess I got my arrow out of order here. That's going to give me 15Q. This cancels, and that's going to be 75 or 0.75 cents. I should say 0.75 or 75 cents. All right, so divide by 0.15, Q is 5. And if I have 11 coins, then that means I have to have 6 dimes. Put the 5 in for Q, subtract it from 11 is 6. Corey and Santos are running a team relay race. Corey runs twice as far as Santos. Together they run 15 miles. How far did each person run? All right, K for Corey's number of miles, S for Santos's number of miles. K plus S has to equal 15, and it said Corey runs twice as far as Santos. So Santos went the least amount, so we got to multiply Santos miles by 2. And like we said, K plus S equals 15. All right, this is a substitution. You have the K by itself. Substitute it in for K. 2S plus S is 3S. Divide by 3, S is 15. So take the 5, double it. 2 times 5 is 10. So Corey ran 10 miles. Santos ran 5 miles. Next, oops, I don't know why I got another 3 here. So a little typo error there. That's okay. Carissa has $550 in her savings account, and she has to pay $5 each month to her parents for her cell phone. Cody has $200, and he saves $20 each month from his job walking dogs for his neighbor. At this rate, when will Carissa and Cody have the same amount of money? And when or how much will that be? Come on, mouse. So since we're saving and spending by months, we're going to let M equal months, and we're going to let capital A equal the amount in the bank. So Carissa's amount in the bank starts at $550, and then we subtract $5 each month, so minus 5M. Cody starts at $200 in his bank account, and he adds $20 each month, so plus 20M. So this is a situation where we kind of have Y equals mx plus b. We just got the variables at the back end. We're going to take 550 minus 5m, put that into Cody's A, because we have them both equal to A, and solve for m. I'm going to add over the 5m to the 20. I'm going to subtract the 200 from the 550 to get 350. Divide by 25, m is 14. So that takes, how long does it take them to have the same amount of money? 14 months. How much will they each have? Put 14 into either equation. All right, so I went with the easier multiplication, 20 times 14. Okay, that's 280 plus 200, 480. So in 14 months, they will both have $480 in their savings. All right, the admission fee at a local zoo is $1.50 for children and $6 for adults. Oh, here's that our ticket question again. So we're going to let A for adults, C for children. I don't know what happened to my C for the number of children. It should have a C here equals number of children. I apologize for that. C plus A equals 2,200. Those are the people that went to the zoo. 150 times C, $6 times the A for the adults. Then they took in $6,450. 1.5 is smaller, so we're going to multiply that negative 1.5 to this equation, move it underneath. Negative 1.5c minus 1.5a equals negative 3,300. Add that together. 6a minus 1.5 is 4.5a. Remember the c's canceled. Calculator, 6,450 minus 3,300, 3,150. Then divide by 4.5, a is 700. Go back to C plus A equals 2,200, put 700 in for the A, subtract it over. C is 1,500. So there was 1,500 children and 700 adults that attended the zoo. All right, Colin goes to a fast food restaurant and orders some tacos and burritos. He sees on the nutrition menu that tacos are 140 calories and burritos are 560 calories. Oh, he changes his mind of what he wants to do, so he only ordered 9 items and consumed a total of 1,680 calories. How many tacos and burritos did Colin order and eat? All right, so T for tacos, B for the number of burritos. He ordered 9, so we're going to have T plus B equals 9. Then we're going to have a calorie, because we have the total calories, 140 calories times the tacos, 560 calories times the burrito, for a total of 1,680. Those are huge numbers. So when you see this, you might want to slow down and say, let's make my life easier. I notice that the 140, the 560, and the 1,680 all end in zeros. So let's scratch out the zeros. That makes it 14t plus 56b equals 100. Wait a minute. Okay, hold the phone. These are all even numbers. Let's reduce it a little smaller, because if we can multiply any number to this first equation, you can also divide. So the first time I divided by 10. Now I'm going to divide all these numbers by 2. 7t plus 28b, wait a minute, equals 84. Let me check my calculator here. 84 divided by 7. Oh, it goes in there evenly. Goes in 12 times. So 7 goes into 7 once. 7 goes into 28 4 times. 7 goes into 84 12 times. When you get some of these things that have these huge numbers, always take the smallest number, 140. Divide it into both of these numbers. 560 divided by 140 is 4. 1,680 divided by 140 is 12. They usually always do that. So they want you to work harder, not smarter. So when you get big numbers, think about dividing out a common value. Now, what's nice about this is now I just have to multiply my first equation by -1. Negative t minus b equals a -9. Okay. 4b minus b is 3b. 12 minus 9 is 3, divided by 3. He ordered 1 burrito, therefore he must have ordered 8 tacos. A farmer saw some chickens and pigs in a field. He counted 42 heads, so there's 42 animals out there, and 110 legs. This I always got to giggle at. These animals are moving around, especially chickens, and you were able to count up 110 legs. Right. Anyhow, let's have fun with it. Determine exactly how many chickens and how many pigs he saw. All right, C for the number of chickens, P for the number of pigs. There was 42 heads, which means there's 42 animals. C plus P equals 42. Now, chickens have 2 legs, and pigs have 4 legs. So 2C plus 4P equals 100. Wait a minute, those are all even numbers again. So again, just like we did with the tacos and the burritos, let's divide out a 2. 1C, 2P, and 55. That way when we multiply this by a -1 and move it underneath, we get -C minus P equals -42. My C's cancel. 2P minus P is automatically P. 55 minus 42 is 13. We already found the number of pigs. Put that in, subtract it from 42. There was 29 chickens. All right, now a little bit more difficult problem. This is called a mixture problem. It's still set up the same way. You want to find your object equations first. All right, a chemist has 10% and 60% solutions of acid available. So these are 2 separate jugs, one with a 10% solution of acid and the other one with a 60% solution. So the second one has much more acid in it than the first one. How many liters of each solution should be mixed together to obtain 37.5 liters, where it's going to be an 18% acid solution? All right, so I'm going to let X represent the number of liters of the 10% solution. Y is going to be the number of liters for the 60% solution. And so my liter equation, that's going to be my object equation, that's going to be X plus Y equals 37.5 liters. Now, there's 3 rates here. The 10% gets multiplied to the X, that's 0.10. The 60% gets multiplied to the Y, that's 0.60Y. Then the 18% is for the 37.5 solution. So I have to multiply this together because they really didn't give me a total for this acid solution. All right? So go to the calculator, multiply that out. 0.18 times 37.15 becomes 6.75. All right. Smallest coefficient, 0.10. Multiply this top equation by negative 0.10. Move it underneath. We have negative 0.10x minus 0.10y minus negative 3.75. All right, cancel the x's. 0.60y minus 0.10y is 0.50y. 6.75 minus 3.75 is 3. Divide by 0.5, we get a 6. Take your x plus y equals 37.5. Put 6 in for y. Subtract it over. X is 31.5. So we had 31.5 liters of the 10% solution, and we had 6 liters of the 60% solution. Now, how do I know if this makes sense? Well, think of your percentages. Is 18% closer to 10% or 60%? It's much closer to 10%, which then tells me I have to have more liters of the 10% solution than the 60%. So I need just a little bit in comparison to the 10%. 6 liters added to 31.5 liters of the 10 will get us to an 18% solution. All right, number 10, the Nut Shack sells hazelnuts for $6.90 per pound and peanuts for $4.90 per pound. How much of each type should be used to make a 32-pound mixture that sells for $6.15 per pound? Again, another mixture problem. So I've got my object, so it's going to be my hazelnuts, H, that's how many pounds of hazelnuts, and capital P for the pounds of peanuts. There's 32 pounds in my mixture, so H plus P is 32. Now multiply your rates. 690, so 6.9 times my H, 4.9 times my P, and 6.15 times the 32. All right, so 4.9 is the smallest. Plus, we need to multiply that out, so that's 196.8. Negative 4.9 gets multiplied to the first equation. That's the smallest coefficient. Move it on down below. Negative 4.9h minus 4.9p equals a negative 156.8. Get your calculators out for those multiplications. I will have 2h. My p's cancel. 196.8 minus 156.8 is 40. Divided by 2, h is 20. So I have 20 pounds of hazelnuts. Gets substituted in for h. Subtract 20 from 32. We have 12 pounds of peanuts. That's what I need to make my mixture. Number 11, slightly different problem here. An airplane flies 7,980 miles into a wind for 19 hours, then the return trip takes 14 hours. Find the speed of the airplane without a wind and the speed of the wind. So we need the formula distance equals rate times time. So I'm sure you've encountered this. So if you're going to go on a road trip and you set your cruise for 70 miles per hour and you drive for 3 hours, you can tell yourself, well, in 3 hours I've gone 70 times 3, 210 miles. All right. Now, however, though, we have to find the speed of the plane. So I'm going to use the variable p and the rate of the wind. So there's actually two rates going on here. So this r is going to be in parentheses. If you fly with the wind, all right, the plane plus the wind speed is going to speed things up. So let's say I'm flying at 300 miles per hour and I have a 20-mile-an-hour wind and it's pushing directly behind me. My speed of the plane is now 320 miles per hour. If it's in reverse, now I'm 300 miles an hour in my plane, I'm flying into the wind. Now I got to subtract 20 from my plane speed, and that puts me at 280. So with the wind, you always add the two rates. Against the wind, you always subtract. Remember, it's going to be P minus W, not W minus P. The wind can't be faster than the plane. So if we put in our information, 7,980 in for D, and with the wind, it took 14 hours. Against the wind, same distance, but the time was 19. Now, here's where the author is going to try to make you work again harder and not smarter. Do not multiply into 14 or the 19 into the parentheses. Notice that the w's are already opposites of each other. I would like to keep it that way. So since this is times 14, let's divide 14 into 7,980. Calculator told me 570. Do the same thing with the 19. Divide it in. 420. Now, if this didn't divide in nicely, okay, then I'm going to multiply those in. But predominantly, these always divide nicely. Now I bring the 420 minus PW over. My W's are opposites, just add them together. 570 plus 420 is 990. P plus P is 2P divided by 2. The plane speed is 495 miles per hour. Now take one of these two equations right here, the blue or the red one. I went with blue because everything's positive. Put 495 in for P, subtract it from 570. The wind was at 75 miles per hour. All right, number 12. Our last problem. A combined total of $56,000 is invested into two bonds. One that pays 4%, the other is 8.5% simple interest. You made an annual interest of $3,950 off the $56,000. So again, I'm going to use X and Y because I really don't know the names of my bonds. So I'm going to say X is going to be the amount of the 4% bond. Y will be the amount of the 8.5% bond. Now, how much did I totally invest? 56. So 56,000. So X plus Y equals 56,000. Then your second equation, you got to multiply the 4%, 0.04 times the X, 0.085 times the Y, and our total interest was 3,950. This would be your interest equation. 0.04 is the smallest, so we're going to multiply the negative of that to all my terms. We get negative 0.04x minus 0.040, just because I want to line it up under the 5y. And 0.04 times 56,000 is 2240. It's just got to be negative. Add them up, and we get 0.045y. The x's canceled. 3950 minus 2240, 1,710. Divide by 0.045. 38,000 was invested at the 8.5% rate. Then 56,000 minus the 38,000, we'll subtract it over. X is 18,000 at the 4% rate. And that wraps up